Oh, I was muted. So all this while, it was just a pantomime and some lullaby music, which is very loud in my ear, but hopefully not too loud for you. Welcome to a special Friday evening edition of The Coding Train with me, your host, Daniel Schiffman. I don't know how to pronounce my name all of a sudden. I'm here, as I sometimes am on the internet, to read to you from my favorite storybook, A Million Random Digits. If you would like to lie down and close your eyes and fall asleep, you should feel free. I think I last left off on page 2. 77,513, 3,820, 86,864, 29,901, 68,414, 82,774. Next time, we'll keep reading. Okay. Yes. All right, so it's Friday. I'm in a completely empty building in a room with no windows. I feel like I have no idea. I've been not in this room all day, but doing stuff all day. This is what's becoming something of a regular habit, meaning the second time that I have followed up my morning live stream with an evening live stream. Actually have some tea with caffeine in it, which is a terrible idea, but it seemed a little bit necessary. And I'm here not to code something, although I will write some code, but to talk to you about something that I really don't understand, nor is it really that relevant because it's somewhat obsolete in the sense in the JavaScript world, but I'm here to talk to you about prototypes. What is a prototype? Why do you use it? When do you use it? What does it mean? Does it help you do anything? I don't know. I don't know if this shtick is working. Okay. All right. Oh, there's a video of Douglas Crockford explaining prototypes. Oh, you should just go and watch that one. Go to leave this right now. Okay. So let me checking. I see the YouTube chat is going. I see the Slack chat is going. Okay, so I noticed there were a couple new viewers in the YouTube chat. So if you are new here, my name is Dan, and I come sometimes online, typically on Fridays, live broadcasting coding tutorials or coding challenges, which are like tutorials, or lots of rambling talking. I like to listen. I should read all my complaints. I get some really excellent complaints in my YouTube comments. Really, I have a wonderful, supportive, and really terrific audience. But I do often get the complaint that I ramble, I talk too much, I laugh nervously, I'm very nervous. All these things are true. They're legitimate complaints. I welcome all of your complaints. I prefer them as handwritten letters addressed to Brian Williams, care of NBC. Thank you very much. Okay, I don't know if anybody gets that joke, but I meant to have a like boom, but I don't. I have a drum roll though. Started getting some new sound effects. Can you hear this? I can't hear it. How's the balance between the sound effects and me?
As always, I always forget the this dot, this dot, this dot, this dot.
Too loud music?
This dot, this
Music
dot.
is too loud.
This dot, this dot, this dot.
I'm sorry, I might have blown out your ears. Better?
This dot, this dot.
The keying is a little bit off, yeah. Okay. I forgot that I was actually on a live stream. I just started listening to the music and enjoying it. And music is too loud, sorry. Okay. I got to deal with the so much to do with my sound levels. Okay, but my hair is okay, right? I hear my hair is a little bit transparent. It's getting more and more gray. Should I be concerned? If you watch some of my old videos, my hair is much less gray. Anyway, what were we here for? Prototypes, yes. So it's about 7:30 p.m. I will be here until perhaps 8:30 p.m. Then I really got to go because I got to get home, go to sleep, got a weekend to do, all sorts of stuff. Swim lessons, not for me, but anyway, never mind. You don't need to know about my weekend. I'm procrastinating. I really don't want to do this tutorial, but I have to because I committed to it. So for those of you who didn't tune in this morning, I made, let me just get that running actually. I'm going to show you why I'm here to do this. What's the chance that this is actually in the right directory? So let me show you one. I did a couple things. I did a 3D visualization of earthquakes. Good enough. Okay, so this is, hold on, I got to fix the code. Because I just realized I was testing something out with the code to see how it would work. And if I go to here and return it back, whoops, okay, I think to this is the default. Oops. Okay, so this is what I made earlier today. It's a lot of dots making up the word train, and as I move the mouse around, oops, I don't know why this wants me to do this. As I move the mouse around, there's a force that pushes the dots out of the way, and then when I move the mouse away, they come back to their spot. So this was a demonstration of steering behaviors, font paths, particles, forces, whatever you want to consider it. So with this particular example, I did something new in my code. Not here, I used vehicle.prototype. Fortunately, I did not use a quaternion. And as you know, if I ever say the word quaternion, I anticipated a little bit too much there. I have to immediately run away, usually leave the room, but that shtick wouldn't really work. This is shtick. You're not supposed to announce when it's shtick, by the way. Okay, so is anybody watching this? Usually I expect more activity, at least in the Slack chat. Okay. Guillaume, I don't know why sometimes I know somebody on Twitter and I know somebody in another, like whether in a YouTube chat or a Slack chat, and I don't make the connection that they're the same person, even though it should be so obvious to me that they are. So now, thank you, Guillaume, for your, who's in the Slack chat, who is, whoa, 10,000 steps. Watch is buzzing, the camera went off. Okay, I get a lot of steps here. This is really just, we should do some like exercise videos. Could I just do, maybe I should like get some exercise while I'm in here. Okay, so everybody's here. Melvin is handwriting complaints. Thank you very much, I appreciate that. Excellent, okay. Prototype. Ooh, Animation Slayer is 9 years old and watching. That is amazing to me. Welcome, Animation Slayer. Thank you for watching. I hope, this channel isn't necessarily geared towards kids. My son is in fact 8 years old, just a year younger than you. My daughter is 5 years old, quite a few years younger than you. Sometimes I just show them my videos and they're like, I don't have any interest in watching this. But if you can enjoy it and get something out of it, then that's wonderful. I might suggest maybe you already have experience with coding, but certainly if you don't, looking at something called Scratch. I actually would, and I was kind of thinking that I wanted to do some more coding tutorials geared for younger people or kids that, but anyway, too many things to do. But thank you for tuning in. Okay. Coder10 asked if I've heard of P5 Dimensions. It's a new P5 library, and Coder10 is a co-contributor. I should do an episode about it. I would love to do that. I have not heard of it. I haven't been keeping track of all the different libraries that have been posted to the P5 website, but I will definitely take a look. Maybe tweet me. That's usually @Schiffman is a good way to remember. You could also suggest it to the Rainbow Topics GitHub repository as an issue, and that's where I'm kind of keeping track of a list of things. I have to say, I have this problem, which is that there are so many things I would love to cover. In a way, we love to just do this every day and kind of churn through a lot more material. Some things that I have intended to do, I have to kind of research and figure out. And some things are just things that I could look at or do, or things that I know how to do from a couple of years ago that I haven't had a chance to make a video about. So anyway, maybe I should switch to the whiteboard camera when I run away. That's a good idea. The whiteboard camera is not on. How do you, so AYC Lenny asks a question, which I'm going to read, which is going to cause me to have to do this. Let's see if okay. Lenny asks, how do you pronounce quaternion? Oh, ow. Oh, I think I heard something. Kind of ran into the wall there. Hi, everybody. I'm coming back over here. Oh. Okay. Maybe let's not, it's kind of like Voldemort, you know? Let's not name the mathematical 3D or 4D rotation algorithm that shall not be named. This is like, someday I will try to make a video about said algorithm. Not today. Okay. I did not live stream for 8 hours. This is a second return live stream. I better get into this content because I do have to leave at some point. As much as I enjoy the ridiculousness, I feel like I'm a little bit loopy in these evening live streams. Not that I'm not just always loopy. Okay. I sort of hit my foot against the wall. Now my toe is a little banged up. It's going to be fine. Okay. Some of you have asked for the kitten song.
Unicorns and rainbows and
This is a song made on SoundCloud by Lost GH Bear. So let me get myself set up while I play this music.
Kittens and rainbows and cupcakes. Notice that. Look what I get. I'm really losing my mind.
I'm really losing my mind. It sounds a little bit off kilter in that. How's the volume on the? You're using the same mug. Okay, wait. We're gonna do prototypes. I'm trying to think of, let me get set up here. I need a blank sketch. It's hot in here. The lights are hot. Okay, I'm gonna call this prototype discussion. And the point of this actually is to eventually demonstrate this idea of inheritance. So that's going to be part 2. I don't know if I'll get to part 2. Then let me open this with Adam. And I'm going to delete the font here. It's not part of this example. I'm going to delete vehicle.js. And when I say I don't really understand prototype, I'm not joking. I'm going to try to figure it out. I mean, I have some baseline of understanding. I'm not coming from zero, but I have tried to explain this before and I always botch it. So we'll see how this goes.
Okay, we're gonna do it. I'm really getting to something. I need my sound effect.
Okay. I don't think I need draw right now. And refresh, prototype discussion. I need the console. Whoa, console is giant. And back to Adam. Get rid of vehicle.
All sorts of text generation analysis things that I will use continuously over and over again.
Okay. How is the font size in this console here? Can you read this?
I'm really losing my mind.
It feels like it's a little bit small. Okay. All right. Turn the music off now. It feels like it's a little bit small. That feels like it's a little bit big. Object. That's probably better. Let me see if I can give myself a little bit more space. Huge. Huge. Okay. I think this is what I'm going to live with. Okay. Wow, somebody in Germany is watching this at 1:40 a.m. Amazing. Okay, here we go. Easily legible in full screen. Thank you in all the chats that I'm looking at. Okay, hello everyone. I think I'm just about ready. Let me come over to the whiteboard here, and I actually got this like whiteboard cleaner thing, but I think we're just going to have to live with this. Okay. So I gotta really think about this. Maybe we should like read like the Wikipedia page about prototype just like softly. Here, just to get warmed up. Prototype JavaScript. Maybe we'll look on the Mozilla documentation. Oh, I'm in the wrong camera. Nearly all objects in JavaScript are instances of object. A typical object inherits properties, including methods from object.prototype, although these properties may be shadowed, aka overridden. However, an object may be deliberately created, for which this is not true, e.g. object.create null. Or it may be altered, so that this is no longer true. Changes to the object prototype object are seen by all objects through prototype chaining, unless the properties and methods subject to those changes are overridden further along the prototype chain. This provides a very powerful, although potentially dangerous, woohoo, it's dangerous, mechanism to override or extend object behavior. The timing worked out so well. Boy, I'm gonna get lots of complaints. Can't wait for those YouTube comment complaints. It's gonna be great. Okay. Okay, so I think I can maybe do as well or slightly better, probably worse, but I can do something a lot. I think we can make sense of this. So what I'm going to do is I think I'm going to start with this here. I'm going to say clear. And the music was a little jarring against my voice. Balance wasn't good. Was the balance okay? I really want to like hear about my sound balance. This is what I'm very concerned with. Okay, let me get my marker out. And here we go. So this is going to be the video tutorial. And if you're new, what I often do is I do these like long live streams where I waste a lot of time. That's what you're watching right now. Or you might be watching this as an archive. And then during the live stream, there might actually, luckily, be some cogent, salient, I don't know what the right term is, points raised or demonstrations about programming that are actually useful. And then those get edited into separate videos that get placed in various playlists I have, coding challenges, regular expression tutorials, GitHub tutorials, simulation tutorials, that type of thing. So now I am moving into the trying to make some sense and do something useful phase of the evening. Music could have been a tad quieter. Thank you for that feedback. It's too bad because I felt like that was like at work. I've been like workshopping, a lot of this music plus talking thing. And I felt like that was like a moment where it was coming together for me. I felt it. I could feel you. Okay. Okay. Oh, Raja in the chat is making a Minecraft mod. I would like to know what you're using to make a Minecraft mod. And I had this like fantasy that I could create some kind of like hybrid processing Java Minecraft modding environment tutorial thing. That was like a fantasy I had when I went to Minecon in London. What year was that? It was like recently. It was summer 2015, I guess. Because it wasn't last summer, it was the summer before that. That was great. Okay. Yeah, first of all, people in the chat are saying, oh my God, all these people are here. They're 9 years old, they're 12 years old, they're learning to code. I did a little bit of coding when I was in middle school, or even in elementary school. I think I did some basic programming on an Apple II Plus. And then I think in middle school, I even did a little bit of assembly languages, tiny bits. Then after that, I didn't actually do any programming until I was 27 years old. So there you go. You too can be an old person on YouTube talking about programming, not having done it for many, 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 many years. Okay. Oh, wait. I'm getting a note in here. Two most important things that from Ada. Thank you, Ada, in the Slack channel. She writes, two most important things that prototypes give us that classes, true classes don't, is maybe what she said. One, inherited simply by copying the prototype. You can copy the prototype from person to foo. I try to avoid using foo, by the way. That's like a kind of like placeholder name for an object, foo or bar. And somehow I like to use things that resonate more with like real world examples. But foo is now a person. You can even copy merge two prototypes into a single object's prototype, and you have gestalt inheritance. Ooh, this is way more advanced than I. So Ada, I'm going to be relying on you in the chat to correct me in the Slack channel, to correct me and give me some tips as I go here. Okay. I'm going to press the buttons on the camera. I got to get started with this because now it is actually 7:45. I wasted 20 minutes. And I can press these buttons, give myself a half an hour here, and okay. So when you make an object, it has a prototype. You make a function, it has a prototype. I feel like by the way, there's a really good tutorial. I should have watched this today. That would have helped so much. Objectplayground.com. This definitely needs to be in the definitive guide to object-oriented JavaScript. If you want to understand this stuff, you should watch this instead. It's terrific. I probably watched this a year ago, but it's super helpful and has some nice diagrams and is very well prepared and explained, and it's very thoughtful. And what I'm going to do likely will not be. Okay. Okay. Here we go. Chrome extensions. Yeah, that's coming. In case this is your first time watching, I also have a train whistle. Oh, and I have some new train sound effects. Oh, no, I don't. I was getting some new train sound effects, but I do have this now. Okay. Okay, here we go. I'm going to try it with this timpani sound. Hello, welcome to a video about prototypes. So, first of all, I should say right now, you should probably turn this off and go do something else, because I'm about to make a video about something that I don't really entirely understand. And also, a little bit, you could kind of make the argument it's a little obsolete or a little passé, or, why aren't you talking about ES6, this new version? Boy, this timpani sound is very long. This new version of JavaScript. So what I'm going to attempt to do, I made a coding challenge earlier today. You can go, it'll link to it from this video. It was a coding challenge. I'm just going to show it to you, actually. I should have had this up. It was creating the word train out of little dots. And then as I moved the mouse around, the little dots would move, and then they would come back. So I made this coding challenge, and I used a particular bit of syntax where I created objects and attached methods or functions to the object's prototype. And so I wanted to try to make a video to at least cover what is a prototype in JavaScript, and why is it kind of relevant, or why might you use it, and how does it relate to this concept of inheritance, and maybe also this concept of polymorphism. Okay, whatever. I'm going to workshop this. This could use some work, but I'm trying new stuff, new material. Yeah, how am I doing? Not so great. Okay. So what is a prototype? So first, I'm going to just sort of work. I'm going to close this, and I'm going to come to some code. And in this code, I'm going to write a constructor function. I could probably start further back, but I'm coming through a baseline of maybe you've watched some of my other tutorials and you've seen me create objects with a constructor function. So a constructor function, and I will talk about ES6 and classes towards the end of this video. So before you start typing in your complaints, why aren't you mentioning ES6 and classes? Okay? Function, and I'm just going to say there's a particle. I'm going to use a particle. Actually, it's fine. Particle. Function particle. This.x equals 100. This.y equals 99. So the idea of this constructor function is I can create an object that has those two properties associated with it, an x property and a y property, and this keyword, right? JavaScript knows that if I ever say var p equals new particle, the new keyword indicates to JavaScript that, that function, right, that you wrote is not a regular, all functions are the same. It's a function, 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 it's a function. But functions can be executed in a slightly different way as constructor function if you use the new keyword. The new keyword says execute that function as a constructor function, meaning make a new object and assign that object to the keyword this. So it's binding the context of the code that's happening inside that function to the keyword this. Boy, I think we need a whole video about the keyword this. I think I've covered it and mentioned it before. But this is this keyword in JavaScript that can be kind of pointed to the current context, pointed to different things based on what you're doing. And here I want to make a new object, so I need something to point to it. I'm going to use this. Okay, so I'm making a new object. Now, let me actually do this rather instead of in the code. Let me actually just go to the JavaScript console itself. And I've got that code loaded in the background, so I can do things like var p equals new particle. And we're going to see now, if I look closely at that object, there it is. It's a particle object. It has an x property and a y property. What else does it have? Well, it has this proto property, pointing to object. So let's come back to that in a moment. Okay, we're going to come back to that in a moment. Hold on. Okay, now I'm going to go, and I'm going to say something like this.show equals function. Equals function. This dot point. Oh, no. Sorry, I lost my train of thought. I'm in P5, so I'm going to call the point function this.x, this.y. So like I'm going to add a function to the object where I draw it as a point. So, and actually what I'm going to do is I'm going to say var p, just so I don't have to keep typing that in the console, p equals new particle. So now I'm going to reload the page, and I'm going to type p again. So now it has, come on. Whoa, okay, something went wrong here. Oh, there it is, sorry. It's there. So now it has three properties. Show, which is a function. You can sort of see that here, and there's other stuff associated with that. There's so much to talk about. We could be here forever. We won't talk about it all. An x property and a y property. Now let's think about this for a second. I'm going to make another particle. Var p2 equals new particle. p2. Now, both of these particles, oh boy, I've got this computer here. Okay. Both of these particles have an x and a y property. And this makes sense, right? They should each have their own x and y property because I might say p2.x++, right? And now p2, its x property is its x has moved to 101, but I don't want p to have moved. I want to be able to treat those properties of it individually, those sort of the data of these particles, where they live on the screen. So it makes a lot of sense that those would be attached to the new object that was made in the constructor function. But let's think about this. Do they really each need their own individual show function? Couldn't I just have a show function that was just kind of living somewhere that I could say, hey, particles, when it's time to show, go and grab that function. You could both use the same show function because you're both going to be displayed as a point. You'll use your own data to show yourself at different places on the screen, maybe with different colors, but you don't actually each need a show function. And right now, when I make two particles, they each get their own x and y, which they should, and they each get their own show function, which works, but is a little bit unnecessary. So how can I possibly make this a bit more efficient? And I'm kind of backing into the concept of prototype. This isn't normally where you would start, but this is one reason why it's useful. I can instead say, forget about having a function defined here. I can write some very strange looking code, particle.prototype.show equals function. So now, and I'm going to do the same thing. I'm just going to put that code in there. And now we are going to look at what does this particle look like in the console. P. The particle now has an x and y. What happened to the show function? It's down here. Oh boy, so now we've lost it, and I think I need the whiteboard. This is the moment where I think we need the whiteboard. Okay, I'm over here at the whiteboard. I'm walking very awkwardly, not so sure what I'm going to draw yet, and feeling a little nervous here because I don't know. This is where it gets a little bit tricky. So what I'm suggesting here is this object, all objects, P1 has an x and has a y. Now I could also add a show function, but I could also just add a prototype. And that prototype is going to point to particle.prototype. And particle.prototype has a show function. So this is kind of what's often referred to as the prototype chain, so to speak. Although the chain isn't very long yet, I really want to show how this can then be chained further and further and further. So this is the and that's where it's getting show. So now, if I say P2, and I have an X and a Y and a prototype, this is also pointing to particle.prototype. So if I say P1.show, it looks, is it in here somewhere? Nope. If it was, it would execute the show function. I could override what's in the prototype by having this particle have its own individual show function. I don't know why I would do that, but you could, and maybe you can think of why. Not here, go look in the prototype. There it is. So this object is going to get functions that are available in the prototype. Now, strangely enough, what I'm going to do for a brief moment is leave this here and show you a reason why this can actually be incredibly powerful, I don't know if that's the right word, but incredibly useful as a JavaScript programmer when you're using existing JavaScript objects that come from other libraries. So for example, am I over here now? Yes. For example, let's say you want to use, actually a good example, array is a good example of this, but I'm going to use the P5 vector object. So let's say you have a vector. I'm going to say, I'm going to make this a global variable just in case I want to look at it in the console. V equals create vector, 3, 4. Now, V has functions like, and so if I go to the console and hit refresh, I can say v.mag. The magnitude of that vector is 5. It's a 3, 4, 5 triangle, actually, if you look at the sides and the hypotenuse. That's the magnitude of that vector. Now, what if I wanted to say what is the magnitude? Actually, that is a function. What if I wanted to just double the values of that vector? So I know I could say v.multiply by 2. That's a way that you can actually double the values of a vector, and you can see now it's 6 and 8 instead of 3 and 4. But what if I wanted, I feel like the vector object, because I'm going to do this a lot in my program, I just want to be able to say v.double. Well, of course I'm going to need an error that says uncaught type error v.double. Well, where is the multiply function? Let's look at let's look at P5 vector, right? Let's look here. All of these functions are in P5.vector prototype. All of that is down here. This is all the stuff listing what's in the prototype. So, and I got to talk about what this underscore proto thing is, but down the things listed below are part of the prototype. These are the properties specific to that actual object instance, the object itself, not part of the prototype, which is sort of a shared amount of functions for all objects that are created from that prototype. So, what if I wanted to add something to this? Well, this is not something you could normally do in a lot of other programming environments. Oh, I got this class or this object or this thing, I'm just going to modify it in my program. No problem. Well, guess what? In JavaScript you can. I could say p5.vector.prototype equals, .double equals function. And what would I do in that function? I could say this.x, because whatever object gets called, look at that object's x property, times equals 2. This.y times equals 2, this.z, because the vectors actually have 3 components. So now I've modified the P5.js library by adding something to P5 vector's prototype. Any vector, anytime in my code in this sketch will always now suddenly have a double function. And we can see that because if I hit refresh and I type v and I look at all the functions available in the prototype, suddenly there's a function called double right there. It wasn't there before. So this is how, I don't know if I'm going to say, if I'm going to pull a correct example, but there's JavaScript libraries like underscore. Underscore is probably a good example that suddenly when you have that library imported, you have all these new array functions or other kind of helper functions. Those are, JavaScript libraries can augment, so you could add your own functions to arrays by saying array.prototype. Shuffle. I don't think that's a function. Like you could write your own function to shuffle the array. Maybe that's already existing JavaScript function to like randomize an array. So there's all sorts of possibilities of what you can do by augmenting via the prototype, because objects that are connected to a particular objects are connected to their prototype all get those functions. And even if you make those objects from if you make an object that's part of a library, you can augment that thing's prototype and get those functions. Oh, I was doing well until I tried to, scratch that whole last 2 minutes. Okay. So how are we doing here? So now, that's a bit. So now let's return to this. So here's the thing. I mean, that's actually mostly. I feel like that's mostly what I wanted to talk about. I think I almost feel like pause, just time out. We're going to edit this for when I go over here. So I got to think about this. Maybe I can get a little feedback now from the chat. What I was thinking is, Ethan in the chat writes, it would be so much easier to follow this if I could speak in italics. I wonder if there's a way, a little like thought bubble pop up. So what I'm trying to decide if I want to just kind of like wrap this up and then do a second video which looks at inheritance more specifically. But did I really even define prototype? I'm looking for the chat to maybe give me some play the this dot for inspiration. I'm thinking about kind of wrapping this up. All right, I'll play the this dot while I'm waiting. Turn the volume down. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to read the chat. The Slack, I have a Slack channel for patrons, which if you want to, there's a service called Patreon, which kind of helps to crowdfund some of the work that I'm doing, and you can subscribe to it that way. But I semi-explained it, says Ada, in the YouTube chat. This dot, never forget this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot. I'm not hearing any complaints. I'm going to do this dot, this dot. Oh, talk about proto. Good point. Okay. So I think I want to wrap this video up and mention, now I think, so this is the object's prototype, and I think in the prototype, is proto a property of the prototype? And that points to like object.prototype. Is this correct? I'm going to erase this and then explain it. Is that correct? The thing about the Chrome console is it doesn't really show you exactly the structure of the object. Let me see if I can figure that out. Over here, like I think that if I say particle.prototype._proto is object. So I think I'm right, because if I say P, I can't say P dot, oh well I can say this because it's going to get it from the prototype. But it's coming from the prototype, right? Yeah, comparing classical inheritance with prototype. That's a good point to sort of kind of compare this to classical inheritance. Maybe I'll do that in the next video. Yeah. It is the prototype. Well, particle has its own prototype. But then prototypes are chained. So it has a parent prototype, right? All right, I'm going to have to rely on my own knowledge here. Where's that eraser? P.proto. Okay, so I am going to because here's the thing. Well, okay, parent prototype is the wrong term, says Ada in the chat. No parent prototype. I see that. I'm gonna wait for a further explanation. So I understand that that's the wrong term, but it's kind of like it's chained, right? Because particles prototype is object. I saw Ada is typing. I was waiting for the next. What time is it? 8:07. Okay. Let's see. So what am I doing here? I'm waiting to go back to the moment where I come over here. p.proto.prototype. It's chained. So maybe I just shouldn't say parent. There's a chain. So particle.prototype is chained to object.prototype. And we can, and you can, yes, you can destroy the prototypes. I recognize that. Yeah. Okay. So maybe that's how, oh, I'm in the wrong, the whole time I've been in the wrong screen. Camera, please. I apologize for that. I was in the wrong screen the whole time. Sorry. Okay. So I need to talk about proto, chain, review, adding functions, and everything in JavaScript is an object. Yes, 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 yes. Even arrays and hairs. Everything functions are yes. Yes. But if I say what I was saying, if I say something like obj equals this, and I don't use a constructor function, its prototype is just object. Ah, this is the prototype right here. I get it. So it's confusing. Like its prototype is object. Ah, I see. Chain, yeah. Okay. Okay, I think I'm kind of got this a little bit better. Okay, I guess I can't really, that's fine. I'm going to clear this. Okay, so I'm going to go back to the part where I'm on the board. And, but I think technically that underscore proto is in the, is part of particle.prototype. No, the prototype of our object is object.prototype. Yeah, object.prototype, not object. Yes, I said it incorrectly. Chained as I thought. Okay. This is very helpful, everybody. Okay, yes. I don't know what that was referring to, but at one point I said something correct. Okay, can we do this, everybody? I'm going to move over. And I forgot where I was, but it'll hopefully edit together nicely. Thank you, Mathieu. Okay. Okay, so here we go. So I've mostly wrapped up this first video on prototypes. You know, there's lots of little missing pieces here, lots of little gaps to fill in. I want to, and I'm going to do a follow-up one which goes a little deeper into inheritance, this idea of inheritance, and then another one which goes deeper into this other concept known as polymorphism. But let's just, one thing that we need to figure out here is what was that underscore proto thing? So there's something in JavaScript called the prototype chain. And right here I made these objects calling the particle is a constructor function, and this assigned actually the this made these objects that have the properties x and y with it's from particle.prototype. Whew. But that underscore proto is referring to a property of the prototype, which is a pointer in a way, a reference up the prototype chain. And what this actually points to is something called object.prototype. Everything in JavaScript, everything, arrays, functions, everything, except for some primitive var x equals 5 numbers and undefined, everything is really an object. And all objects ultimately have as the sort of top of the prototype chain. Of course, you can mess around with all this stuff by creating objects with null and destroying the prototype, but that's a little less practical or relevant to this video. All objects, if you go all the way up the prototype chain, go get object.prototype. And there are methods here. There are methods like hasOwnProperty, which is actually, this is actually a really easy, interesting thing to look at. hasOwnProperty. Let's just investigate this function hasOwnProperty for a second. So I can say p1.hasOwnProperty because it doesn't, that property, hasOwnProperty isn't here. Oh, but let's look up the prototype chain to particle.prototype. Oh, it's not there. Oh, let's go to object.prototype. Oh, it's there. I can execute that function. Let's look at what that function does because it's kind of interesting. It's very useful. So I'm going to say p1, oops, oh, just p, sorry, p. This, incidentally, this object prototype is particle.prototype, and we can see the functions. And now look, there's also an automatic property of the prototype constructor that is set automatically to that particle constructor function. That's what happens when you say new. The new keyword says the particle's prototype constructor is that function, particle. So you can see here, particle's prototype proto pointer points to object.prototype. And we can see, look, these are the other functions that come from object.prototype, like has own property. So let me show you what I mean by that. I can say p, like let's say I say p.z. Well, that's undefined. It doesn't exist. It's not a property of particle, and so I could say p.has own property z, false. It is not a property. It's not a property of p. But has own property is a little bit, it's not just is it something that you could say that gives you a valid result? What if I say p has own property x? I should get true, right? Look, p has a property x. Correct. But what, remember particle? I can say p.show, right? That's a function I can say. P.has own property show. False. Why did I get false? The reason why I got false is because show is a property that's in the prototype. So this is a way you can detect if the property is something specific to only that, is like an individual property of that object instance or something that's somewhere else in the prototype chain. And this is actually useful sometimes if you want to iterate overall the properties of an object, even with the prototype chain, you can determine if it's like something you want to ignore because it actually comes from object.prototype because it's not a has own property of the object itself. So I kind of went on a little bit of a digression there, but hopefully this lets you see how do we find something up that prototype chain. So this is a little bit of what a prototype is. I'm sure I missed, I don't know if I like explicitly defined it, kind of backed into it, showing you how you use it and how it's relevant and where you find it in the console. Sure, I missed a lot of pieces here, which I'll come back to. But what I want to look at is what if I want to make other objects? What if I want to put something else? What if I want to have so let's say I have a generic particle object that has all of the physics, basic physics of a world it's going to inhabit. And what I ultimately want to do is I want to have turtles and fish and bees and all different kinds of creatures that have lots of their own functions and properties, but they get all of their physics stuff from, say, a generic particle object. How can I have a turtle.prototype, which has a lot of stuff specific to turtles, but has all the physics from particle.prototype that has all the functions from object.prototype. How can I do something called inheritance? How can I have objects inherit from other objects that I'm defining through prototypical inheritance in JavaScript? So that's going to be in the next video. It might not come out for a little bit, but it will come out eventually. Maybe you're watching this in the future and they're all there, or I've deleted them because these videos are a disaster. So look for it. It might be there. Now, I should mention once again that what I'm showing you is a part of the JavaScript language from the version that is informally known as ES6. So there's a consortium, EMCA script, blah, 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 that determines and specs out the JavaScript language. It's an interesting, complex topic of how that's done and who has a voice there, which I think it's a separate discussion. But the new, and it's actually not even that new at this point, but it just, there's still some browsers that don't support it. The newest version of JavaScript, ES6, has a different model and syntax for this involving something called class. And if you have programmed, as I have, in Java or other classical programming environments, so to speak, this is more of like a classical model of inheritance, and there's a key. So at some point, I also want to look at that. So in this continuing series. But first, I want to figure out this prototype stuff. I want to get inheritance, also talk about this thing called polymorphism, and show you some examples that make use of it. Okay? Thanks for watching this particular video, and I will see you in a future one about prototypes and inheritance. Okay, so that was sort of reasonable. I think I got through some stuff there that was helpful. Can you show how to call the prototype in example for calling within draw? Would it still just be p.show, p2? Yes. Sacrifice Productions asked, that is absolutely correct. The syntax of using the particle object itself, it doesn't change at all. I'm still calling show just like it's a function. I don't know where it comes from. It might be has own property of the object, or it might be somewhere up the prototype chain. Okay. The question is, do I have the wherewithal, time, energy to take this one more step? I'm not so sure. I almost want to leave this as is and see what kind of questions I get, and then kind of come back next week and do the next step. And maybe I could do, yeah, because I've got to go by like 8:30, and I don't want to rush it and mess it up. Do it for the kids. Yes, for the kids. You know, I'm thinking of my own children right now, and I would like to, small coding challenge, cough, cough. I would love to do a small coding challenge. What could be a small coding challenge? Oh, let's do the butterfly wings. That's going to be a small coding challenge. Okay, so that'll satisfy you. I don't have the wherewithal right now to do, and maybe I could do it in CodePen. Is it simple enough to just do it in CodePen? No, I'll just do it with my. I don't have the wherewithal to do another video about prototype. I'll just do that next week. It'll come, and I am going to do a small coding challenge. Why not? I'm sure I'll be here for another hour now. Okay, prototype discussion. Butterfly wings. Okay. I'm seeing Ada is posting some wonderful examples of inheritance and stuff in the Slack channel chat. Thank you very much. And those will be very useful for me when I come back and follow up this video. Okay, make Call of Duty in 10 minutes. I've never even played Call of Duty. I wish I had time to play video games. That would be fun. What's funny is I realized I'm kind of addicted to this game called Dots on my phone. I realized this dot, this dot, this dot, this dot's on. Okay. Particle, prototype, tetra. Okay, get rid of all this. This is a terrible idea, but I'm doing it anyway. How did I agree to this? I'm not so sure. Butterfly wings. Okay. There we go. Oops, nope. There we go. Okay, now what I want to do is pull up one of my favorite artists, Rose Pipkin, and go to bots and moth generator. So let's see. I kind of want to find one that's maybe a little bit more realistically aligned. Let's just do this. Okay. Okay. This dots game. Thank you for all these wonderful chat messages. Thank you, Ada, for the shape inheritance example. Okay. I don't know why I really like the timpani sound. It's very quiet. Okay. It's probably like already 8:30 now. I took that much time. No, it's kind of a reasonable amount of time. I really have some keying issues today, but whatever. Okay. I think that I probably won't do a separate intro for this. I'm just going to show this at the beginning and then make the video. By the way, I have no idea what I'm about to do, so we'll see how this goes. But I really want this to be like a 10-minute coding challenge, and then I'll leave you guys. I'm going to leave, and you guys over the weekend or next week can enjoy riffing off of it. Okay. And let's see. All right. I don't know if this one merits the train whistle. I need a bunch of these. So. Shoot, that was terrible. I hope if that broke anybody's ears, I apologize. Clear your whiteboard before I start. Good point. Where is my magic whiteboard eraser? I almost don't want to, though. What if I need this for next week? Erase it anyway. I gotta wash this whole whiteboard. It really needs a washing. Okay. Okay. It's all right. If I have to leave a little bit after 8:30. Let's make sure there's no emergency text messages. I'm not seeing any emergency text messages. I'm reading my Twitter mentions, which there's no use in me doing. I'm fixing my hair, and it is getting warmer in this room. Oh, I'm in the wrong screen. I really have a bad habit. Okay, here we go. Crooked Lust asks, will you ever do coding challenges in Python? Not so likely, but I would love to have a guest do some Python stuff. And I do at some point, we'll be looking into connecting certain JavaScript or processing programs with Python libraries. So that's something I hope to do at some point in the future, yes. But Python's not really my wheelhouse, so to speak. I would love it to be, but you gotta give me some time. Okay. We are good to go. Okay. Oh, that was really loud. Hello, welcome to another coding challenge. This has been a highly requested coding challenge. I don't know if that's really true or if I'm just making that up. It's in my own mind. Inspired by one of my favorite artists, Katie Rose Pipkin. I will link to her Twitter and her website in this particular video. One of her projects, one of my favorites, is called the Moth Generator. It is a Twitter bot that generates moths. It makes names for them, it makes designs for them. They're algorithmic, they're generative, and they're wonderful. So looking at this, somebody had asked me once, or I thought of it myself, who knows where the genesis of this is. Well, how does a project like this really work? And time out for a second. I feel like Katie Rose Pipkin wrote an article about this. Like, somebody in the chat tell me if I'm like moving, if I'm like losing my mind here. Generative essay or something, I don't know. About a bot interview. I kind of feel like, didn't she write a write-up about this? I guess I'm imagining it. Let's see, writing. No, projects, about, Let's look at her Twitter. I don't know, I'm like remembering, I'm having a moment where I like read an article where she went over her, oh look, she has a Patreon. Ooh, I didn't know that. I'm totally subscribing to this Patreon. Somebody remind me. I'll remember. Okay, I was going to say maybe it's like a pinned tweet or something. Okay. Okay, so anyway, nobody in the chat is giving me a link. This is highly requested by me, yeah. Okay, I'm gonna pick this back up. Sorry, Mitya, that's going to be an awkward edit. Where was I there? Projects, bots. Which one did I have on the screen? This one? Close enough. Okay. I will be using JavaScript and the P5 framework. So how could you do something like this? So I thought, let's try. Now, there's a lot of thoughtful design that's going into her work, but I thought we could tackle at least just this idea of parameter-based design in a way. How can we write, how can we write an algorithm that generates a particular kind of design with some specificity and yet a lot of variety? And boy, will I not even scratch the surface of the creativity and the kind of visual delight that's in this particular example. It's certainly not my expertise or talent in terms of that aspect of programming and design. But I thought at least we could look at a quick example of like, well, what might be a technique for at least generating a wing pattern? And maybe you might choose to make your own generative creatures as well. So let's think about how you might do this. So one thing in terms of making a wing pattern is symmetry. So whatever I do to create this algorithm on one side, all I need to do is flip and mirror that on the other side. And the technique that I think I will attempt is using polar coordinates. So I have several other videos where I've done this, and I'll link to a particular tutorial about polar coordinates in this video's description. But the idea here is I could use some very simple math to draw a shape that looked like this, calculate all these points, right? Because what I can do is I can think of every point as some angle, the Greek letter theta for an angle relative to the x-axis, and some distance out from the center, r. And I can determine this point's xy by saying x equals r times cosine of the angle, y equals r times sine of the angle. And I encourage you to look at the link to a video about that particular math function in more detail if you want to go and find out more. But right now I'm just going to use this formula. Now, what if instead of r, so theta is something that I'm just going to increase over time. What if r changes? For example, as I get down here, r becomes less. So I don't know what that's going to look like, but the r, that would kind of give an outward wing. So we could even just try that at first. But also, what if I were to use something like Perlin noise, some randomness, to kind of offset these points to give it some other kind of pattern? So let's just give that a try and see what happens. Here I am. Okay, so now we will begin programming. So I'm going to go over here, and I'm just going to do this in setup because I'm at this point I'm not going to have any animation. Oh, that'll be interesting to see. Maybe I could animate it in some way. So let's just first draw one side. So what I want to do is say var. I'm going to start with I'm going to do a for loop, and I'm going to use a for angle. I'm going to go from. This is a little bit tricky here because if I want to go from up here to down here, or from down here to up here, typically this would be 0, and this would be pi divided by 2, or radians of 90 degrees. So I think what I want to do is go from negative pi divided by 2 to pi divided by 2. So let's do that. So I'm going to start at negative pi divided by 2. And I'm going to say a goes all the way up to pi divided by 2, and a increments by some arbitrary amount, 0.1. Then I'm going to say var x equals r times cosine of a, var y equals r times sine of a. And what is r going to be? Let's just make r equal to 100 for right now. Then what I want to do, and I guess what I'll do is I'm going to use the translate function to offset everything from the center. Translate 100, 100, and I probably should say width divided by 2 and height divided by 2. So everything is relative to the center. Because a canvas, right here, if this is the canvas, 0, 0 is actually by default here. So this thing that I'm drawing would be sort of half off and over here. So I want to translate 0, 0 to the center, so everything's relative to that. Then what I'm going to do is I'm just going to draw a point. I'm going to say stroke 255, and I'm going to say point x comma y, stroke weight 2, 4. So let's just see what I get. There we go. So I now have that particular path. That's pretty good. And I could do something where I say, I don't know, start r equal to 100, and then I could say, for every point, r minus minus. And you can see, I kind of don't know what that did. That's not really like a wing, but it's something. So it's almost like the other way around in a way that I want to do it. But the point is, I can start to vary r. Okay. Now, I want this to look more like a wing, so what I'm actually going to do is I'm going to say begin shape at the beginning and end shape. And then instead of drawing a point, I'm going to say vertex xy. What that's going to do is going to make a continuous shape along that path. So you can see that. Now it has a fill. Maybe I don't want that. I don't know if I want the stroke weight to be 4. Let's take this stuff out here. I'm going to say stroke weight 1. And then I'm going to just to sort of see that fill, I'm going to give it sort of like an alpha E fill. And we can see, there we go. So there's my wing. Okay, we're done. Thank you very much. Good night. We got to make this a little bit better. So I got to think about other ways that I could vary what that R is over time. So one thing is Perlin noise. This is a video that uses Perlin noise. Oh, maybe you're watching this video and you have no idea what Perlin noise is. So this video is now going to be inserted into the Perlin noise playlist. You might not have come to it there, but if you back up a few videos, and I'll link to it in the description, I have a whole video covering what Perlin noise is, how the algorithm works, and what Perlin noise is. Just to give you a short, quick explanation of it is, hold on a sec. Sorry, pause. Let me go back and I just need to pause for a second. There's some like crazy stuff going in the chat which distracted me. Okay. Mathieu, I'll just come back to what is Perlin noise. Hold on a sec, everybody. I am coming back. Okay. What time is it, by the way? 8:33. You're not doing so badly. Okay, cosine A times 2. That's an interesting suggestion. What is that going to do? Oh, yeah. Okay. The Rose pattern thing, there's so many possibilities. So many possibilities. Okay. That's a great suggestion. Thank you. I'm going to kind of add that in. Okay, I'm thinking. Okay. So if you are wondering what Perlin noise is, you can check this video's description and I will point you to a whole set of videos that describe it, the algorithm, what it is, how it works in more detail. But the way that you might understand it simply just for this video is it's an algorithm that allows you to pick random numbers. It is a random number generator, so to speak, but those random values are smoothed, meaning the number you pick is related to the previous number you picked. And so if I wanted to create some kind of smooth randomness like the edges of a butterfly or moth wing, this could perhaps be an algorithm that I could use. Okay, so let's think about how we could do that. So using Perlin noise, I need to look at Perlin noise values over an offset, a period of time or an offset along a dimension. So I'm going to create a variable called xoff for x offset. And this is, again, explained in my Perlin noise videos a bit more. So you can pause, go watch those and come back. I'll stop saying that. I'm going to say x off plus equals 0.03 or 0.1. I'm just going to pick a value. And what I'm going to do is I'm going to say r equals, I'm going to get rid of this r minus minus thing, which was kind of unnecessary. I'm going to say r equals, so first I'm going to say var n equals noise of x off. So the noise function always gives me a value between 0 and 1, generally clustering around 0.5, but sometimes more, sometimes less, moving randomly, that sort of thing. So what I want to do now is say r equals map n, which has a range between 0 and 1, to, I'm just going to say, between 50 and 125. So let's look and see what I get. Now I'm getting somewhere. Look at this. I've kind of got this strange curvy-like thing. So let's play with this a little bit more. Let's look what happens when I increase the offset faster. I don't know if that's more or less like a moth wing. Also, like I'm incrementing by 0.1 for every angle, and it probably makes sense for me to kind of have a bit more resolution there. So now that's a little bit crazy, so I could go back and move a little bit slower through the Perlin noise. Look at this. Almost right. I wish I had seeded this because that's just like sort of perfect to me. Look, I kind of have a weird sort of wing of a moth right now already. So there's more that I could do to this, but now one thing is I just want to at least flip it and see the other side. How do I do that? Well, incidentally, here's the wonderful thing. Perlin noise is deterministic, meaning it's always going to return the same exact value for the same x offset. So there's no reason why I couldn't just go, and do this exact code again. And I'm sure I could do this without copy pasting it by like having an outer loop around the inner loop. But just for the sake of argument here, I'm going to just literally copy paste that code again, but change the range of angles. So what I want to do now is go not from negative pi over 2 to pi divided by 2. I want to go from negative pi over 2 to, I guess if I'm going this way, I want to go to negative 3 pi over 2. Is that right? I think that's right, because I'm continuing to go in the negative direction. So let's try that. I'm sure there might be another way to think about it that would be easier, but let's go from negative pi divided by 2 all the way to, as long as it's greater than, remember I'm going in a negative direction now, a negative 3 times pi divided by 2. And this is probably a ridiculous way to write these values out, but it's good, fine. And then a minus equals, and then exactly the same code. There we go. Now look, I have exactly mirrored it. Now I could make it just one continuous shape, which would make a lot of sense to do that. And I wasn't thoughtful about designing it in such a way that my incrementation value is exactly going to get me the whole way. So let's actually fix that, because that's sort of like, we want at least to like close at the bottom. So I'm going to say var d angle, like delta angle, dA for delta angle equals pi, right? Each side of the moth or the butterfly is pi. Pi divided by some amount of points that I want. I don't know what makes sense. 100 points? So that's like the incrementation. So I want to increment by dA, and then down here decrement by dA. And let's take a look. So this is with 100 points. It still didn't get all the way to the end. Do I need to say greater than or equal to maybe? Less than or equal to, because I want to get one more point in there. Whoops. What did I mess up? Oops. Sorry. I have a little bug here. I really feel like it should get to the end and close. Maybe what I need is to actually just say close. No, that's just drawing that line up there. What did I miss here? Pause for a second. Yeah, that would. Oh, that's a good way of doing it. Hold on, pause. I'm going to edit this because my nose is running. I have a little bit of a cold. Okay. I'm looking. I like Alka's suggestion, which is to just use the map function. I kind of like that suggestion. So let me try that and see if that fixes the problem. I can leave out end shape between the loops. That's really what I should do. But the problem with that is, okay, too many suggestions here. Okay, let me think about how I want to do this. The problem that I'm experiencing is that what I did is I went and then I went sound effect being here. So really, if I want to make it one continuous shape, I need to do this. So then n just goes down. No problem. Okay. Whoops, let me. So I'm still not getting this closed for some reason, so let me try a different tack. Actually, what I think I would like to do is go all the way to the bottom and then just keep going around, so I make it one continuous shape. So let's take out this end shape here and this begin shape. Now, this is not going to work because it's going to go all the way to the bottom. And actually, what I'm going to do is do this mapping just between 100 to keep it more on the screen. It goes all the way to the bottom, then it jumps up to the top, and then goes all the way around here. So what I actually need to do when I get to the bottom is to keep going. So in that case, and I actually could condense this into just one loop, but I'm going to say, what I'm going to do is I'm going to start at pi divided by 2, and I'm actually going to go all the way to positive 3 pi divided by 2. I'm going to keep going at the bottom, right? And then a plus equals. But what I'm going to do is have offset not get reset, but I'm just going to say minus equals. So the noise values are going to be going up, 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 and then to mirror it, I'm just going to go back down, 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 all the way to the other side. I think this will work. Oops, I only got half of it. What did I miss here? A starts there. A is greater than 3, less than, and then going up. There we go. So now I have it as a perfect symmetrical shape. I can refresh it, and I can get a whole bunch of different, I don't know if I've really made moth wings. I've kind of made, and I really would need to think about how to make this more moth-like. Now, I think I have a kind of suspicion here That's something that might be useful to try. Do you recall, I don't know why you would, that I recently made a video about polar roses math. So I'm going to look for this Wikipedia page. This is a particular algorithm to create these sort of petal-like formations on almost like a flower pattern. And you can see this looks very, very similar to this sort of polar to Cartesian coordinate transformation I'm doing, but there's this K, so to speak, in front of R. And so what I could potentially do is also kind of combine cosine maybe with add this in. So let me do this. So I think if I do this, if I say R equals cosine of theta times the noise value, and maybe I'm just going to, cosine of A times the noise value. I'm just going to do one side for right now. Whoa. What have I done? Whoa. I have to think about this some more. What if I take this out for a second? Yeah, oh, but now I'm not mapped times 100. Oh, because it's going negative. Yeah, I'm missing a parentheses. Where am I missing a parentheses? So, you know, hold on, I'm thinking. Pause. Let's see here. I really should do this as one loop, because now I'm doing ridiculous. Look at that. Because if I do both sides, let me see if I get an interesting result here. Oh yeah, look at this. This is good. This is good. Oh yeah, and actually if I flip that, okay. Okay, so I'm going to now pretend I discover this in real time. Where was I? Where did I leave this? Let me go back to where I show the Polar Rose Wikipedia page. Okay. So let me go back to here. So how could I apply this into, how could I apply this sort of rose formation into the moth pattern? Okay, so let's think about this. So if I were to do the polar rose literally, I might not use noise at all. And this is, by the way, very silly now that I have these two loops doing the same thing. I absolutely should condense that into one loop and just have the noise change at different parts of it. But I'm going to just leave it kind of this way for right now. I could say cosine of 2 times the angle, just to like try something, times, 100. Just going to kind of put that polar rose code in there for a second. Whoops, and come back here. And look what I get. I get that kind of rose formation. But what if I combine that, and by the way, what if I combine that with, you can almost see, if you look at it diagonally, that looks like almost like a butterfly flapping its wings. What if I put the noise in with that? So instead of multiplying it times 100 as like R, what if I multiply the result of the noise function? And then I get something like this. Now, in the chat, I'm seeing the suggestion to do sine. So let's use sine instead of cosine. And there we go. And now it's on its side. But you can see that's kind of getting us somewhere. How could I rotate that? Or maybe it's, yeah, because it's symmetrical top to bottom now, the way that it's. So I could do, like, right now, just so we can like look at it differently, I could just say rotate by pi divided by 2. There we go. So look at this. And now I could kind of play with, I don't know what the number of points is or what this x. So this should really be dx, just for the noise value. I'm going to just put the variable in here. And I'm going to put this in here. And now I'm going to refresh it. And I could try different values for different things, like move through the noise faster, move through the noise more slowly. Whoops. Move through the noise more slowly. I get something much more. Well, I could move more slowly, but have like, many more points, and now I get something like this. So there's a lot of possible ways I could start to explore this. Now, one thing I would like to show you before I go is what's really interesting about Perlin noise is we can always add, let me just get it to some baseline, we can always add some sort of additional dimension. So right now I'm seeing the Perlin noise values for one dimensional. The offset of the R, it's like, even though this is a two-dimensional drawing, I'm picking the noise values over a singular dimension. I think this camera is about to shut off. It's not shutting off because the other one shut off. Yeah, it did. Okay. I'm anticipating it. So a way that I could, there's lots of interesting animations and color and other design ideas I could add to this, but what if I just wanted it to kind of like wiggle in some way? How can I change the Perlin noise values over time? Well, one way to do that, and there's a lot of different approaches I could take, but one way is to add the second dimension. So the noise values that I'm picking, the second dimension is actually frames of animation. So I get a set of noise values, then I get another similar set of noise values, then another similar set of noise values. So what I'm going to do here is I'm going to, and I defined R twice, somebody in the chat had mentioned that. I'm going to put all of this stuff in draw. So now I have a draw loop. Same program, but it's drawing it over and over again. I'm going to add a global variable called yoff. I'm going to set it equal to 0. And in my noise function, I'm going to say n equals x off, y off. That second dimension, I'm going to pick values. The second dimension being not a two-dimensional space. I've done that in other videos where the second dimension is actually like pixels in a two-dimensional space. I'm still asking for singular values to offset the R, but those values are going to change. The second dimension is time here. Then so every frame, I'm going, well, first let me add this in, plus 0.1, but I'm going to comment it out. So even though I added the second dimension, I'm getting just this. But now I can have that change over time. And you can see, look at what I've got here, this kind of crazy, weird animation of those values changing. So now I don't know what this is exactly, but this is my creation of butterfly wings, moth wings, animating using Perlin noise and some trigonometry in P5. And there we go. I kind of like this. I'm really excited and curious to see what you, the audience, the viewers, make of this. Hopefully you can make something more creative. You can think about color, you can think about design, you can add more features to it. Maybe you could actually try to see if you can make it so that the wings look like they're waving and flapping. Share with me what you do on Twitter, in the comments, all that sort of stuff. And just looking at the chat to see if I did anything terribly wrong. It wasn't on its side once I used sign. So I've got there's a lot of things you could add to this to make it more efficient, right? Condense those loops, figure out about the orientation better. But I'm going to leave the code as is and those things as exercises for you to do to make it better. Times x by the sign of frame count. Okay, wait a second. I'm just getting a comment from C. Manny in the chat. This video really should be over. So you could stop watching it. Times x by sine of the frame count. This here, sine of frame count. Again, I really hate that I'm doing all this twice. Sine of frame count. Now let's just do this. Whoa, okay. So frame count, how about times 0.01? So I really should have a counter. I could use y offset. You know what I could just do? I already have y offset. So I'm going to use y offset. There we go. Look at it flapping. It looks like it's ready. And maybe I want to do y because I wanted to sort of flap along its x-axis, I think. There we go. We've added something here. So I don't know what kind of crazy monstrosity I have, if that's really flapping, but you get the idea. We added a little quick extra feature there so you can see we've got flapping moth, butterfly, wiggly, jiggly wing things in P5 with Perlin noise, with trigonometry, and I can't wait to see what you make of it, okay? So I am going to leave this. So many more improvements I could make. I have to resist, and I'm going to leave this video. Thank you for watching. I will see you in a future coding challenge. Enjoy. Have a great, whatever it is, day, evening, morning, afternoon. Give somebody a hug. Smell the butterflies. That's not a thing. The roses, flowers. Anyway, appreciate the nature. It's a wonderful thing. Okay, goodbye. Okay. Yes, the rotation I had was totally unnecessary. I should probably map that to not go down to 0. So I look forward to all your improvements and okay. Okay, so I think this is it. It's 8:52. I've got to get going. And I will see you all. I will not, the next time I will be live is next Friday, not next Friday morning. Usually my live stream is Friday morning, but I have a conflict for next Friday, so it will be sometime in the afternoon or early evening. And there will be, right now I have 4 videos that will get published as standalone videos next week. Oh, 5. 5, I think. I have this butterfly one. I have the earthquake 3D. I have, what was the other one I did? Yes, absolute value. Oh, yeah, that's a good point. What was the other one I did this morning? Well, I can't remember this for the life of me. Oh, the steering thing, the prototype thing, and a guest video from Emily Shia making a matrix rain simulation. So all those will hopefully come out next week. Okay, unfortunately I don't have a lot of time to take questions. I've just got to go. I'm going to play my new goodbye song because the music might be very loud. Sorry about that. It is time to go to sleep, to go home, to go to sleep, to have dinner. I haven't had dinner. I barely ate anything today. And I appreciate all of you. I could read to you a few more numbers before I go. 7,531. It's a good one. It's a very good one. 72,883. 51,242. 3,894. I appreciate all of you. I appreciate your feedback. I enjoy it, your comments, your support. I get so much. It's great. I really appreciate it. There's no sushi ordering. It's a good idea though, okay, Weekman. And I will see you guys. Train animation. Yeah, that's got to come. Goodbye.